I'm Rajan Merchant welcoming you to our first episode on this special topic of elliptical holes in thin plates. About 100 years ago, on March 14, 1913, Sir Charles Edward Inglis presented a paper on stress analysis for an elliptical hole in an infinite elastic plate. Since then, many researchers all over the world have worked on this topic. Over the next few episodes, I'll present results of my work which is developed since April 2011. I will offer some answers and I will raise some questions. I sincerely hope these presentations will generate a lot of interest among physicists, mathematicians, civil engineers, mechanical engineers, and others. I hope ideas presented here will be useful to people working in the field of solid mechanics, applied mathematics, and related fields. For the benefit of students and people who are new to this topic, I'll attempt to present very complex ideas as simply as possible. For further information, I can be reached at 416-725-0909. A few weeks ago, I read parts of a web course on machine design. A sentence from that course caught my attention. This is the last sentence in paragraph above figure 3.2.1.2f in the exhibit shown here. The figure shows stress concentration due to a circular hole. The sentence above the figure reads, "This is the theoretical or geometric stress concentration factor, and the factor is not affected by the material properties." I'm not sure what the authors meant by the first part, which reads, "This is the theoretical or geometric stress concentration factor." However, I would like to comment on the second part, which reads, "and the factor is not affected by the material properties." On this issue, I would like to show part of a paper published in 1994. Expression 36 in this paper related the stress concentration factor to the final dimensions of the hole as shown in this exhibit. Furthermore, the final dimensions were related to initial dimensions, far field applied stress, and Young's modulus for the material. Thus, this 1994 paper related stress concentration factor to the initial dimensions, far field applied stress, and Young's modulus of the material under consideration as shown in expression 37. To arrive at this relationship, the current configuration and the elliptical coordinates were employed while using the engineering strain definition and the linear stress-strain relation. My recent research reveals that for materials exhibiting a linear stress-strain relationship in the elastic zone, the stress concentration factor depends on initial geometry, far field applied stress, Young's modulus, as well as the Poisson's ratio. Furthermore, even for such a linear elastic material, the expression that relates stress concentration factor to these four factors depends on the definition of strain and the definition of stress used in the analysis. Many researchers have used and continue to use the small strain assumption. In order to simplify their analysis, they use initial dimensions where expected deformations are small. Hence, in case of a circular hole, when they use initial dimensions instead of final dimensions, they conclude that the stress concentration factor using expression 36 is 3. On the other hand, some researchers who apply small strain assumption use initial dimensions to begin with. Yet, after calculating the stress field, they compute the displacement field to conclude that a circular hole at the beginning becomes an elliptical hole at the end. I would like to emphasize that a circular hole at the beginning does not remain circular after the application of uniaxial load, even if the expected deformation is small. Hence, the stress concentration factor does not remain at 3. I have no disagreement with persons who are satisfied with the small snare assumption and use of the original configuration. Instead, my analysis allows us to compare results obtained using the original configuration with results obtained using the current configuration. I note that a circular hole at the beginning may remain circular after the application of biaxial loads in certain proportions. It is also possible that an elliptical hole at the beginning may become circular after the application of certain amount of uniaxial load. I have considered these possibilities in my analysis. For now, I conclude that the stress concentration factor does depend on material properties. It is therefore important to acknowledge this dependence on material properties and emphasize that under the small strain assumption, this dependence is ignored. In coming weeks, I intend to present details on various issues related to this topic with examples so that they are easy to understand. These issues will include nonlinear stress-strain relations and nonlinear strain definitions in elastic as well as plastic zones. Goodbye for now.